Let's continue to our final subtopic, which is on solving indices. Right, so these are expressions, and then below here are equations. The difference is equation needs to have the equal sign. So to solve an equation, it means that we want to find the values of the variable that can make the equation true. So for any type of question, like the log equations that you have done the exercises and the search question, you really have to check your final answer. And how to check your final answer? Just substitute the value of the x's into the original question without changing any positions of anything. There are three methods in solving index equations. The first one is by comparing base and index. The next one is by taking log of both sides. And the last one is by using substitution. We are going to look at examples to apply these three methods. Example 1. 1a. The first question has 5 to the power of x equal to 125. Are we going to use the first method, second method, or third method? Well, which one is the easiest? That's the one that we are going to use. The first method is to compare the base and index. Can we do that? Well, of course. 125 can be written as 5 to the power of 3. Then we just compare the base and the index. Make sure we have the same base before we compare the index. So the answer is just x equal to 3. Next question. This is 7 to the power of x plus 1 equal to 12. Can we do the same method as 1, which is comparing the base and index? Well, if you want to use that method, you have to make sure that 12 is also written in the form of 7 to the power of something. But can you write 12 as 7 times something? No, this is not possible. So, since it's not possible, what you have to do is, you have to use another method. Look at the second method, taking log of both sides. That means we just have to write log on the left side and also on the right side. You can also write natural logarithm on the left side and natural logarithm on the right side. It's also the same thing. Make sure they are the same basis of log. Okay, next, what you have to do is, from the law of logarithm, you can bring x plus 1 to the front. So that's what you do. Well, why do you have to do that? It's because the value of x that we want to find is at the power or at the index. Okay, so why do you have to put log both on the left and right side? Is because you want to bring x to the front. So that's why we use the property of log to bring it down. Now we can just solve as always. To find x, just bring plus 1 to the right side. And then the final answer is 0.277. For question C, x to the power of 2 over 3 equal to 100. Now x is not the power of any number, and it's just x equal to something. So what we have to do here is, we have to eliminate this number so that we get the value of x. And how to do that? Just multiply the power with the opposite fraction, like this. Then we can just cancel off. So if we multiply the power with the opposite number, on the right side we also have to multiply the same power. Now we can cancel off the powers of x. So x will be the power x power 1, and then on the right side it's just 100 to the power of 3 over 2. And then you can just press your calculator to solve that. Okay, question D. 27 to the power of x plus 1 equal to 9 to the power of x minus 1. How to solve this? Make sure if you want to compare the base, both left and right side must have the same base. Can you write 27 and 9 to be equal to one same base? If not, then you have to use the second method. When are we going to use substitution method? It's when we have more than one term. For example, like that. But now we only have one term on the left side and one term on the right side. There's no plus of anything else. 27 and 9, can you write them to the same base? Yes. 3 3 to the power of 3 and 3 to the power of 2. Then just expand the powers, and since we have the same base both left and right side without any other expressions on the right or the left side, we just compare the powers or the indices. Next, just solve this as always. Example E, 343 to the power of x squared equal to 1 over 7 to the power of 1 minus 5x. This looks a little bit complicated, but don't worry, we know these three methods. Of course, method 3 is not applicable here. It's because it's just one term or expression on the left side and then one term on the right side. So that's why we don't have to use method number 3. Can we write 343 to a base 7? Yes, it's going to be 7 to the power of 3 to the power of x power 2. Well, how will this be? Remember from rules of indices, if we have something like this, that means it's just going to be multiplied together. But since we have something like this now, just imagine that x squared is like n. You just write it to the next to 3. So it's just going to be 7 to the power of 3 x squared. Since 7 to the power of 1 minus 5x is at the denominator, just take everything and bring it to the left side. It's going to be multiplication. From divide, you change the left, it's going to be multiplication. Next, from the rules of indices, a to the power of m times a to the power of n is just equal to a to the power of m plus n with the same base, right? So that's where I got this. Then why do I change 1 is because I want to apply the first method, which is to compare the base and index. So to compare, if my base on the left is 7, my base on the right must also be 7. As you can see, 1 can be changed to a base of any number to the power of 0. So let's say if our base here is 2 to the power of blah blah blah, then on the right side we can also change it to be base 2 to the power of 0. So it's up to us, because anything to the power of 0 is always 1. But since we want to have the base 7 here, that's why we chose 7 to the power of 0. And only then we can compare the powers. Okay, this is just a quadratic equation, but can you factorize? No, you can't. You have to use this formula. You can just substitute the values of a, b, and c into that formula. This is a, this is b, this is c. You substitute into the equation, and then you can get these answers. Right, example 2. We want to solve these equations. Remember that we have these three methods. So to solve this first equation, are we going to use the first method, second, or third method? Well, like I mentioned just now, the third method will be used only when we have more than one terms. Like this. We have one term here, another term here, another term here. So when we have three terms, usually the third method will take place. Now, to solve this question, first thing is you have to separate the power 2x plus 1. How to separate it is by using the rule of indices, which is a to the power of m plus n equal to a to the power of m times a to the power of n. Next, we have 4. The other bases are just 2. They have the same power, but they don't have the same base. What you can do next is, you can change them to be the same base. Either you change 4 to be base 2, or you change 2 to be base 4, by changing 2 to the power of 2 to be 4. And this is the method substitution. You're going to let the base with the smallest power to be the variable. So let's say it's u equal to 4 to the power of x. So if this is u, then what is this going to be? Well, 4 to the power of 2x can also be written in this form. 4 to the power of x bracket 2. From the rule of indices, which is a to the power of mn is equal to a to the power of m times n. Or can also be written as a to the power of n times m. They mean the same thing. So from here, we can just change this as 4 to the power of x power 2. So since u is 4 to the power of x, you can change this to be u, and then u squared minus 2u minus 35. This is just a quadratic equation, and press your calculator. This is your factorization, and then you get your answer for u. Next, just substitute u back to the original expression. Well, to solve for x, since x is at the power, remember the only way for us to bring x to the front is by taking log of both sides of the equation. So that is like applying the second method. So you just put log or natural logarithm on the left side. So when you put log on the left and right of this first equation, this is what you get. But on the right side, why is there no solution here is because when you put log on the left and also on the right of this equation, you cannot continue any further because this expression does not exist. You can try to press your calculator and see whether there's a value for this expression. So that's why there's no solution here. Next, why we take log both left and the right side is because you want to bring x to the front. After that, you can just take log 4 on the right side, divide it with log 7, and the answer is 1.404. Last example. This question has the same pattern as the A question, but are we going to use substitution here? Well, before you try to use substitution, try to make sure that the base and the index of them are the same. Well, we have the same base here, but now the power, the index, is not the same. This is the power of negative x. So you can't just simply let e to the power of x or e to the power of negative x now. You have to make sure both of these have the same base and index. How to change e to the power of negative x to be the same pattern as this index? By using the rule of indices, which is a to the power of negative m equal to 1 over a to the power of m. Then, from here, you see this is e to the power of x at the denominator. You can just multiply everything with e to the power of x to eliminate the e to the power of x at the denominator. You can see that this is e to the power of positive x and e to the power of positive x also. Ignore the 2 there because you can just change the position to be like this. You can just let u to be e to the power of x, and then it's going to be u squared here. Now this is a quadratic equation. Factorize the equation, find the value of u's, substitute back to the original expression, and then how to find the value of x is by taking log both on the left and right side. But are you going to write log base 10 on the left and right side, or natural logarithm? Which one is better? Well, of course natural logarithm is better because natural logarithm means e is equal to 1. So that's why we just put natural logarithm both on the left and right side, and then bring x to the front, and this is equal to 1. So you will get x equal to natural log 1 over 2 and x equal to natural log of 1. That's your final answer. Please try the exercise out. Thank you.